I was a physician working in a clinic for retarded children when it was discovered that Down syndrome was a chromosome defect. And my husband was going to Oxford. I couldn't practice medicine, but I thought, well, I could learn chromosomes so I could study patients with mental retardation and other developmental disorders. But I got involved in a research project, so I didn't want to go back to the clinic. And I decided, I approached the professor at the University of Chicago to let me have use of a microscope in a dark room, and by the way, would he also pay me? And I only wanted to work part-time because I had 3 children, and he said yes to all of those conditions. As a consequence, I worked with him, although I was doing my own research, which he didn't really understand very much about. He was a hematologist, and it had been discovered at that point that one particular type of leukemia had a chromosome abnormality. So he would ask me to look at the chromosomes of his patients with leukemia. And naturally, since he'd been generous to me, I was delighted to do that. And it turned out, as I looked at these chromosomes from these patients, that they had different abnormalities. I was very lucky that the chromosome abnormality that had been identified earlier in 1960, which was thought to be a result of missing chromosomal material and missing DNA, I found that in fact it wasn't a deletion, but rather was a translocation. That is a switching of the ends of chromosomes. And this was an important observation, even though in the 70s, when I made the discovery, we couldn't tell what it was due to. I mean, what was happening to the chromosomes? Were they the same in different patients? All of that was completely unclear. But in the next decade, they began actually identifying the DNA at the breakpoints and showed that they involved genes that had already been identified as cancer-causing genes, and the translocations actually activated those genes. Wow. So that not only explained what the translocations were doing, it identified genes that were important in the translocation, and finally led to the development of Gleevec, which is an important drug for treating the particular form of leukemia that has this translocation, and it's transformed the lives of those. I think that my research and what it led to in terms of the drugs that now can successfully treat leukemia show the value of science, not only intellectually, but also to the general public, and that science is really an aspect of society that should be supported as generously as it's possible.